It only goes if my sound is on, and I keep my sound on.
I
know. All right, welcome back, everybody. So this is warm-up going over section, the GCF and factor by grouping. So for the GCF of these three terms, I'm going to look at these three terms. I'm looking for what divides each of these terms evenly, or what they have in common, basically. Biggest common factor. So what divides all three of these terms nicely? Noah?
5x.
5x, good. The GCF in this case is 5x. And, you know, it's good form to write it out like that, where the GCF, but did you notice I didn't do that on my key? You don't have to do that. That's not like something that I'm going to force you into doing. That's just good form. All right, so you take 5x and you divide it out of each piece. So we put 5x out, and it becomes 2x to the second. And then we take 25 divided by 5, we get 5. X squared divided out an x, just an x. Now, I divided out my entire term. So what's that become? Minus 1. Good. Not a minus 0, not a minus x, minus 1. Because the x's cancel.
I got it all right. I just like everything's opposite. Like it's minus 5x.
Okay, your GCF, you chose to take out a negative 5x. The only time you would ever take out a negative is if the leading coefficient, like if this looked like this, then you would be taking out a negative 5x.
The leading coefficient?
No. Leading coefficient is far left, which is something that you missed on your quiz. Yeah. Okay. Yes, sir.
So technically, if you did that, you'd still be correct. So would you mark off points on your test?
Well, the problem with that is it's mathematically correct, but if I say to factor, it's not. You know, like it's saying the same same statement.
Yeah.
It's equivalent, but the direction is to factor, it's not technically fully factored if you factor out a negative, and it leaves a negative in the polynomial. Okay. All right, let's take a look here. Because if I said to factor, and you just pulled out the x, did you factor? Yeah. But did you factor everything? No, you forgot the 5.
So you get like half credit?
Right. So it's partially there, but it's not fully there. Same type of thing. All right, let's factor by grouping. Now, remember the order of factoring by grouping. Underline first two. Oh, no. Give me blue pen. Underline first two, underline last two. And then we look at what is our GCF of each piece. Well, what is the GCF of my first set of terms? Danielle? 3x. Good. 3x. So that goes on the outside, and I divide that out of each piece. So that gives me an a plus 5. What's my GCF out of my second set? Noah? 2. Positive 2. So that gives me an a plus 5. There we go. Take a look at that. What's unique about that? It's got that same common binomial, right? So that comes out. And then what's in my second binomial? 3x plus 2. Good. Basically my leftovers, right? My leftovers. The 3x and then the 2. 3x plus 2. Yes.
What's on your board behind you?
Well, I had GCF on the board, and then somebody in my 8th grade class wrote, getting some Kentucky, spelled wrong, fried chicken.
Yeah.
Sounds like a bad student. Look at that right.
No, it doesn't. There's a T.
There's a K there.
It looks like century.
It kind of does. You're right. Kentucky.
That doesn't look like Kentucky at all.
After
I know. It's
When
spelled
I
wrong.
look at that, I
It's
see
not
Kentucky.
after you.
Kentucky?
Yeah. Now,
Kentucky.
that's a C, but it got erased.
Getting some Kentucky fried chicken.
That's the one. Questions on your homework? What questions do we want to go over on your homework? Yeah, Brianna. 16. All right, so we want to factor by grouping here and here. A lot of people said prime. No, it's not prime. There is a GCF out of my first two. Now, is it a numerical GCF? No. It's just G squared. So take out a G squared. Now, what does that leave us with? Well, if the G squared comes out, that's going to be a 2G minus 3. What's my GCF out of my second set of terms? Danielle? 4. So divide out that 4. And we get a 2G minus 3. Okay, 2G minus 3 is one of our terms. G squared plus 4 is our other binomial. Does that make sense? Noah?
You go over 18.
Yeah, same type of thing there. Factor by grouping. Underline first two and last two. Okay, what's my GCF out of my first two? Now, is it just a variable here? No, I've got a number too. 3h to the second. So let's pull it out. Which gets me a 2h minus 5. 15 divided by 3 is 5. Same thing here. Now, if I've got a negative in the middle, what does that tell me about my negative? See, now, Gio, in this case, that's when I would be pulling out a negative. You see in the second grouping how that 8 is negative? That's when my GCF is negative. So 8 and 20 both get divided by 4 easily. So we're going to say that my GCF is negative 4. We divide by negative 4. This is a positive 2h. And then 20 divided by negative 4 is a minus 5. So my binomials are 2h minus 5. And then the leftovers, 3h squared minus 4. I'll tell you right now, repetition is key with all of this factoring stuff. If you're not doing your homework every single night, it's not going to happen for you. Okay, you're going to get to the quiz, you're going to be lost. You're going to be like, I don't know how to do this. And guess what I say? You've done your homework. What's that?
How does that voice go?
I don't know how to do that.
Oh, okay.
This came out of me like, I don't know what to do here. They come up to me at my desk and I go, okay. You know what's crazy though? Sometimes I just read the problem again. Like I'll be like, okay. Like I'm gonna give it my hint. Okay. 6h to the third minus 15h squared minus 8h plus 20. And they'll go,
I do that.
Literally,
all it takes is for you to read it.
Isn't that weird? Like that's
like hearing it said out loud.
That happens to me all the time.
If I come up to you and you say that, I'm just gonna be like, well, that doesn't give me
And I'll be like, okay, go sit down. Yes.
That's like literally how it is. Like when you
There's a video.
just saying the problem.
Yeah.
Literally, it just makes it.
You also
when I'm
record
at
the
home, like,
videos
I'll literally have to
first.
go through the video.
I know. Once
It's
I
just
go
like
through the
hearing
video,
it out loud
I'm used to
helps.
hearing
Yeah.
your
Like,
voice.
I will put a test and we go through the
Yeah,
last
hearing
one.
it, and then like I hear him say something, and because it's like in his voice, I'm like, oh, I remember now he said this after that, but or that. Like, once I hear him say it, it makes sense.
I swear, I'm not stupid.
I'm not actually like insane or like dumb. I promise. I promise there's a reason why it makes sense. Smarter than
I'm always like, I don't know what to do here, but
my GPA might be low, but it's still
Yeah.
That's like what my
I get
mom.
that.
Just like Annie, you're
Yeah.
too close to hang alone. I was like,
I'm
I still have
for no reason.
PTOs.
Oh.
Or I say, I can't tell you how to do it.
I was like, it's not my fault.
All right. So what we're going to do today, yesterday we learned how to factor 4-term polynomials, right? We learned how to factor by GCF and factor 4-term polynomials. The only way we know how to factor a 4-term polynomial is by grouping. Today what we're going to look at is factoring trinomials. Now, you see on your page right up at the top, I have 2 trinomials that I would like you to FOIL. Go ahead and multiply those together. You should already know how to do that. I'm just asking you to multiply. This was on your last quiz. Go ahead and multiply those 2 binomials together. Multiply those 2 binomials together. It'll help us factor trinomials if you can multiply these 2 binomials together. Okay, you should already be done with the first one. Start working on the second one.
You think you're gonna have flooding problems?
We will.
Yeah.
All right, let's take a look at the first one here.
I'll just get it out.
First out or last. X times x. X squared. X times 2. 2x. 4 times x. 4x. 4 times 2. 8. Combine. 6x plus 8. Right? We do okay on that? Let's take a look at the second one here. X times x. X times negative 3. 6 times x. 6 times negative 3. All right, combine like terms. Now, you may be thinking to yourself, why are you asking us to do this? That's silly. We did this on our last quiz. Well, let me remind you that factoring is like division, right? Which is essentially the inverse of multiplication. So when we look at multiplication here, our job to divide is to take the end result and go back this way, right? That's division. That's factoring. Putting this up here. So let's try to see if we can create some patterns. If I started down here, what do you notice about the numbers in the binomial as they correlate to our answers? If I started here, what patterns do we see? What connections do we see to the trinomial as it relates to the numbers in the binomial? What do you see here? And that would also correlate over here as well. Like, for example, this 8.
Oh, I thought the numbers multiply.
Right. So if you're looking at this last number, these two numbers must multiply to get to our last number, right? If I take this 8, I need to find factors of that 8, things that multiply together to get 8. And that will go there and there. But so why not? Why isn't this 1 and 8? Why isn't that 1 and 8 then?
Is there gonna be times when you could answer this like different answers?
No. You know.
Because it's not just one.
Right. Okay. But why could this not be 1 and 8? What would that change my middle number? Oh. Because my inners and outers would not be the same, right? So how do my inners and outers relate to 4 and 2? They add to get to 6. And there's our rule for trinomials. We must look for numbers that multiply to get to our last number, but add to get to our middle number. See, 2 times 4 is 8. 4 plus 2 is 6. And that's how we create our binomial. Now, is that the same rules over here? Because if it's the same rules over here, maybe we can generalize and say for every one of them. All right, what two numbers multiply to get to negative 18? 6 and negative 3. What is 6 plus negative 3? Positive 3. So that's going to be our rules. What multiplies to get to our last number, yet adds to get to our middle number. That's it.
That's like what I was just gonna ask. But like instead of foiling, would we be able to do that like you just square the x's or whatever, and then you take the last number and then the last number on take both last numbers, subtract them, and then multiply them?
Add them and then multiply them. 4 and 2, 6. Added.
Yeah, but that's subtraction.
No. Add 6 plus negative 3.
Oh.
Yeah? Yes, in only one specific instance. Do you notice how there's no numbers next to x? So yes, in that case. And that's actually how we're going to factor. We're going to look at these and say, okay, what numbers that we multiply to get to the last number also add together to get to the middle number. Okay? And I'm kind of bypassing here, but that's really what I was talking about here. If I'm looking at x squared plus 6x plus 8, I'm looking for numbers that multiply to get to 8, yet add to get to 6. And they were 4 and 2, because 2 times 4 is 8. That's not I should write a multiplication symbol or something. Like 2 times 4 is 8, and 2 plus 4 is 6. Is that same thing true for this? Yeah, we just looked at it. X plus 6, x minus 3. Look, I have 6 times negative 3 is negative 18. 6, oops, from here. 6 plus negative 3 goes there. And that is the rule for every trinomial where there's not a number out front, basically. Where there's not a number out front. Yeah. So how do we summarize this? I'm trying to generalize it for you so you can create a rule. Okay? And this is what we have here. You can fill in your blanks on your guided notes there. If you've got a trinomial, x squared plus bx plus c, just putting in letters there, x squared plus bx plus c. You're looking for two pieces in your binomial that will multiply. So we're calling them p and q. You're looking for two pieces that multiply to get to c, your last number. Okay, so we're going to multiply to equal our last, and we are going to add to get to our middle. That's really what that's saying. We're going to multiply to get to our last. We're going to add to get to our middle. We're going to multiply to get to our last. We're going to add to get to our middle term. That's how you factor a trinomial. And I will tell you this right now. If you're one of those people that are good at their math facts, you're going to cruise through this. If you're one of those people that really struggle with your math facts, you should have a calculator next to you at all times. In class, during homework, at all times. Because you're going to need to be doing a lot of math facts quick in your head. All right, so let's get to it here. Let's take a look at this first one. Now, I've got some charts here for you guys. We're going to do that on the front side, but then I'm going to allow you to not have to do that on the back side. Taking a look here, x squared plus 7x plus 12. Looking at this, what is my last term? 12. So what I'm going to do is find all the factors of 12. Now, let's go through the whole list. 1 times 12. 2 times 6. 3 times 4. Anything else? Right, now, could I wrap that around on the other side? 4 times 3, 6 times 2, 12 times 1? Yes, and that will come into play here in a second. But for our purposes right now, 1 times 12 is essentially the same as 12 times 1. You want to know why? Because what is their sum? No, sum. 13. 1 plus 12 is 13. 2 plus 6 is 8. 3 plus 4 is 7. Now, if I flip that around, would that still be true? 12 times 1? Yeah, still 13. Or, you know what I mean. If I add 12 and 1, I still get 13. The order doesn't matter there for a multiplication or addition. It will matter in a second. But for our purposes here, it doesn't matter because it's all positive. So which set of factors adds together to get to my middle term? 3 times 4. So these are my winners here. So what do I do with them? Well, they go straight into our binomials. You create two binomials with an x and an x, and then you write in, you fill in the factors. Positive 3, positive 4. Positive 3, positive 4. And that's my answer. You have to multiply to get to your last number and add to get to your middle number. And once you find those factors, you put them into your two binomials. This is example 1. Let's take a look at the next one. Notice how I get to factors of 18. 18. So you're going to need to be good with your math facts. You should be able to produce the factors of 18 pretty easily. Like they are 1 times 18, 2 times 9, 3 times 6. And then in the end, it would wrap around again. 6 times 3, 9 times 2, 18 times 1. Now, what am I looking to add together to get?
11.
Excuse me? One more time.
11.
One more time.
-7.
Negative 11. Negative 11. Watch your signs. I'm looking together to get negative 11. Now, how do I add to get a negative number if I've only got positives? Okay, so this?
No.
Because what is negative 1 times 18? negative 18. And I don't want negative 18, I want positive 18. So what do I do with this? What is negative 1 times negative 18? Positive 18. All right. So what is negative 1 plus negative 18? Negative 19. Does that even work? Bummer. Okay. So let's put the negatives here. Negative 2 and negative 9. Does that work? Yeah. Negative 11. Bingo. Found them. So we go x minus 2, x minus 9. I don't even need to check the 3 and the 6. Don't even need to check it. Let's take a look at the next one. Now this one's not written in for you guys, so go ahead and write it in. X squared plus 5x minus 24. X squared plus 5x minus 24. So notice that I now find the factors of negative 24. Find the factors of negative 24. Negative 24. Now, if I want to think about the factors of 24, that would be 1 times 24, 2 times 12, 3 times 8. Now, how am I getting those numbers? In my head, I'm just going, okay, 24 divided by 2, it's 12. 24 divided by 3, it's 8. 24 divided by 4, 6. 24 divided by 5, doesn't work. 24 divided by 6 times 4. Okay, so now I'm wrapping around again. Now, here's the deal. I want this to be negative 24. So what do I need to do here? Like, take a look at 1 and 24. Make one negative. Now, negative 1 times 24. What is that? Or sorry, negative 1 plus 24. 23. Okay. Ooh, I gotta move that down a little bit. 8 times 3, 12 times 2, 24 times 1. If I put the negative here, do I get a different sum?
You get negative 23.
I get negative 23. So, yes, it does matter where I put the negative. Okay, it does matter where I put the negative. So it actually like doubles our list. So here's what we actually have to do. Think. Yeah. Huh? Yeah, it's up here. Negative 1 times 24 is up there. So now we have to figure out which set of factors work. And as soon as you get to it, you can stop. What is negative 2 plus 12? 10. Does that work? What's negative 3 plus 8? Does that work? Bingo. There it is. So we can say x minus 3, x plus 8. There's my answer. You know, notice something about, if I wanted to continue this on, this would have been 2, negative 2, negative 5, negative 10. Look at my answers in terms of my sums. If I flip the negative, just understand that the sum turns negative. Yeah? Negative 1 plus 24 was positive 23. Negative 24 times 1 was negative 23. So if I flip where the negative goes, it just flips the sum. Let's do another one. Factors of negative 30. Now, for factors of negative 30, again, I need to make that longer list. Negative 1 times 30, negative 2 times 15, negative 3 times 10, negative 4, nope, negative 5 times 6, and then it can wrap around again, right? Negative 6, and I do have to write it here. Negative 6 times 5, negative 10 times 3, negative 15 times 2, negative 30 times 1.
On the test, we have to write.
I'll talk about that in a second. Okay, let's take a look here. Which set of factors works? 3 and 10? Be careful. I mean, yes. This one is positive 7. This one is negative 7. Which one do we want? the negative. Negative 10, positive 3. So that's my answers. X minus 10, x plus 3. Now, the question I got was, okay, so do we have to write out that entire list every single time, like on the quizzes and tests? Here's what I will say. Let me show you guys something. Like if I went back to this very first problem, and I changed it a little bit, and I said 5. Okay? Everybody look up here, please. If I changed that problem and said 5, do any of these sums add up to 5?
Nope.
So what would you write?
Prime.
Prime. You are not allowed on your homework, on your quizzes, your tests, you are not allowed to write prime unless you show me the entire list. Does that make sense? Because you could go through your homework tonight and write prime, 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 prime. And I don't want you to do that. Okay? If you write prime, you need to write out your entire list of factors showing that nothing works.
Will there be something that has a
Maybe. There could be. Okay? I'm not going to tell you that ahead of time, though. Now, for ones that do work, now flip it over onto the back. Notice the directions now. It says, factor the following. You do not need to fill in a chart. So you do not need to make a list. Okay? I want you to know that you can always fall back on it if you need to. You want to know what I do at like almost every single time? I write out my last term. And I say, okay, which set of factors is going to work? Right. So it's 4 times 1. There it is. And that's all you need to do. So x plus 4, x plus 1. Because I found factors of 4 that had to get to 5. 4 times 1. Same thing over here. Like I want to find factors of 6. Sorry, you don't have this written in. X squared minus 5x plus 6.
It has to be something negative though.
Right?
Because
Negative 6 plus 1. No, wait, hold on. Negative 6 times.
Okay.
Or negative 1 times 6.
Now, I like what you're thinking there. Sid, what is negative 6 times 1? No, times. What is negative 6 times 1? Do I want a negative 6?
Oh, crap.
No. See, that doesn't work.
Negative 6.
But what would that add together to get?
negative 7.
Negative 7. Is there another option? 2 and 3. Negative 2 times negative 3. Yeah? See, this is a deceiving one. This one always trips people up because you think it's going to be 6 and 5, but it doesn't turn out to be 6 and 5. It turns out to be negative 2, negative 3. So it's x minus 2, x minus 3. Let's do another one. X squared plus x minus 20. And you can start writing in 8 as well. X squared plus x minus 20. And then number 8 is x squared minus 7x minus 8. So in this one, I want to find factors of negative 20 that will add to get to positive 1. Factors of negative 20 that will add to get to positive 1. See, again, those of you who are good with your math facts, you might be able to do this all in your head. You might not even make a list.
Negative 4 times 5.
Negative 4, positive 5. Good. Negative 4, positive 5. What is negative 4 plus 5? 1. So it's x minus 4, x plus 5. See, to me, these are like a puzzle. Like, just figure out which piece works.
Can I do this one?
Sure.
Dude, you screwed me up with the negatives.
I know. It's always when that last term is negative that it's a little tricky.
I was going to say negative. I had 3 and 4. I didn't even think about the negatives.
Uh-oh, 3 times 4 is 12, though.
I mean, no, that's not what I had. Actually, yeah, it was. Never mind. Because that equals 7, and 4 times 2 equals, wait.
4 times 8. Next 2 equals 8. Right?
So that one be like x times -1 because 7 is like a prime number, so you can't really like multiply.
You're trying to multiply to get 8, not 7. You're trying to add to get 8 or 7. Yeah. Brianna?
Would it be -5 and -2?
Nope, because that's -10 or +10. Tommy?
-8 and +1.
-8, +1. There it is. X minus 8, x plus 1. Now, how could you check your answer? I know. Love factoring. How could you check your answer?
Like it's by multiplying.
By multiplying, by foiling, right? If I wanted to see if x squared plus x plus 1 minus 20 was worked, multiply x plus 4 times x minus 5, or sorry, x minus 4 times x plus 5. Foil it back together. You should get where you started. Now, at the end of this, I want to show you there are some tricks to remembering what the signs are. Some of you guys might like these tricks because these work every time. Some of you guys are just going to be like, whatever, I'm just going to look at the numbers. Take a look at the last term there. If both of these signs are positive, if I have to multiply to get to a positive and add to get to a positive, these are both going to be positive. Okay? If I have to multiply to get to a positive and add to get to a positive, these are both going to be positive. If you multiply to get to a positive but add to get to a negative, this is the one that's a little tricky. If you multiply to get to a positive and add to get to a negative, both of these are going to be negative. Okay? Because a negative times a negative is a positive. A negative plus a negative is a negative. Negative times a negative is a positive. Negative plus a negative is still a negative. If they are different, and I'm going to show both of these at the same time. See, if our C term is negative, then I've got to have one of each. Because it can't be a negative times a negative, because that would turn out to be positive. It can't be a positive times a positive, because obviously that's positive. It's got to be a negative or positive. Okay? One has to be negative, one has to be positive. No matter what is going on with my first sign, I don't care about what's going on with my first sign. If the last term is negative, the signs are different. If the last term is negative, the signs are different. I put in the bottom there that flow chart that the book gives. I don't love that, but it might help you along the way if you need it. Notice that in the homework tonight, I want you to write down the original problem. Do you have to write out all of the list of factors? No. If you write prime, I should see the entire list of factors that you tried. Okay?
Is that so that we can't get away with just writing something?
Right. You can't just write prime.
I don't think photo math can help you So some things that we try to do on photo math, I don't know what the problem is.
Do we have to pay money for
Oh, I gotta stop the video.
Oh my gosh, you have to stop the video.
Oh my gosh, you gotta stop the video.
You gotta stop the video. Stop the video right now.
It's like urgent.